everybody. Welcome back to another Tuesday's Tech Talk. It is now officially fall down here in Texas. The temperature has dropped. Yesterday was t-shirt and short pants. Today we're having to break out some jackets. But at least I bet we're warmer than the rest of you guys up north. So still thankful to be down here in Texas. Yes, we talk a little slower, but that's okay. I'm going to talk slow today and explain a little bit more about what we take into account when we're designing crossovers. And we've been talking about crossover design for the last few weeks. We've looked at low order crossovers, we've looked at even an elliptical slope, and we've looked at the design aspects of designing as per the acoustic output of the drivers. Today we're going to be looking at and talking about the importance of the acoustic center spacing, and we're going to look at the time alignment of the drivers and how that affects the vertical off-axis response, and then how that affects the total in-room response as to what we hear. So, acoustic center spacing. Why is that so important? And we've got a little demo speaker here. This is a kit that we offer. This is the little N1 kit that we've offered for quite a few years. It's currently not available because we can't get any more of these BG tweeters with the deep back cup. At some point we'll get a supply of these back in stock again and start re-releasing this model, but for now it's going to be used as an example, and one of the reasons it's a great example is because this model has outstanding vertical off-axis response, and the time and phase relationship of the drivers is just unbelievable. So right off the bat, acoustic center spacing. Let's say we have a mid-bass driver here. We've got a tweeter mounted on the ceiling, and we've got a lower woofer in the next room over. How's that going to sound? About like you'd expect. You know, your highs are coming from one spot, your mids are coming from another spot, your lows are coming from somewhere else. And a lot of speakers are that way. A lot of really well-known speakers that I've listened to. You can listen to it and easily hear the highs coming from the tweeter, you hear the mids coming from the mid-range, and you hear the low frequency coming from down low. Because they're coming at you a little bit out of time. The vertical dispersion is messed up. There's some holes in the response there, and it's affecting the room response, it's affecting the imaging. It's incoherent, and what we want is for everything to be coherent. We want everything to arrive in such a way that when you close your eyes, you see a three-dimensional sound stage, a three-dimensional field there of where things are, and they're layered, and they're within that field, and they're not coming at you from each individual driver. So how far will we have to move those drivers to get them back to where they're coherent again? Can we move that tweeter down off the ceiling halfway? Move that woofer from the other room over into this room some point? At what point do they actually blend? And I see a lot of speakers that people have built, so a lot of DIY efforts, some even commercial models. They have a mid-bass driver, then 4 inches above that they'll mount their tweeter. Why do they mount it 4 inches above that? Are they thinking maybe they can spread the sound out? Because it doesn't work that way. Ideally you want these together as close as possible. Ideally would be a concentric driver, a coaxial driver where the tweeter is physically aligned with the voice coil of the woofer. They're inside of each other, and as you move vertically or horizontally off axis in any direction, you're not changing the time arrival of anything. You're still keeping the same amount of time that it takes for the highs to get to you as it is for the mids to get to you. And we can still do that really well and really effectively still, even with a separate tweeter and woofer. It depends on the wavelengths of where it's crossing, and it depends on how far they are apart. We can make it to where the off-axis looks just as good as a lot of concentric designs. But you have to take that stuff into account. You got to remember, if the microphone is at the tweeter axis, you have to design the filter so that it keeps the drivers in phase at that axis, and you have to consider what it's doing as you move vertically. As you move vertically, the woofer's getting further away in time. As you go lower, the tweeter's getting further away in time. And at a certain point, you've got enough phase rotation or enough change in delay to where one is arriving out of phase from the other, and it's causing a big hole. So that's what you want to avoid. You don't want it to cause a big hole. You want the vertical off-axis response to be just as smooth as the horizontal off-axis response. You want it to be the same. When you have a deep hole somewhere in the vertical off-axis response, that reflection off the ceiling will be uneven. The reflection will be what it's seeing if you're looking at it from an angle. So if you're looking at it from an angle and the woofer's delayed in time versus the tweeter and there's a big hole there, then that reflection off the ceiling may be a little bit of a spike at 3 or 4 kHz and then a huge hole, and then a little bit of a spike down low, and it's as if the sound is somewhat in and out. And if you guys have ever noticed, look up in your listening room. Usually the ceiling isn't treated. I mean, it's one of the most important surfaces in your room, and they're typically not treated. It's the biggest reflection area. A lot of times you see the same problem with the floor. If it's a hardwood floor, ceramic tile floor, things like that, you get just as much reflection off of the floor. If you've got a carpeted floor, you got some absorption there, it's usually a lot less of reflection. As you notice, when you put carpet in your house, you put treatment on the walls, you do things that absorb sound, the room is less hollow, less echoey. Everything sounds better when you're not dealing with tons of reflections. Well, hey folks, that reflection right above your head is another one of those areas that you really have to consider. It's good that if you treat it, if you put some panels on it, if you do some diffusing, something to break it up, be amazed how much effect it has. But you also have to take into account that this speaker, or any speaker, is going to produce an in-room response. In other words, it's what you hear is what it's doing within the room, and it's dispersion in all directions. So if you got a tweeter that's 6 or 8 inches tall, it'll have very limited vertical dispersion because of the height of it. You're well within its beaming frequency, and as you get off axis of it, you lose it. All the highs are gone. So a lot of guys will say, yeah, I don't mind this tweeter being this tall because I'm just going to listen at seated level. I'm just going to listen right here. But you don't just hear right there unless you're outdoors. What you hear is a combination of what it does within the whole room. So all of that stuff becomes important. It's very important how high that tweeter is if you're using it as a single device. And it's really important what that vertical dispersion is. So when we design a filter, what we'll do is there's ways that we can shift phase or time delays a little bit between them. And ideally we want to be on axis of the tweeter. We want it to be in phase, which we consider tweeter axis to be like ear level when we're listening to the speaker. And when we go up vertically, we want it to still be in phase. In this case, the crossover point is about 1800 hertz, so the wavelength is still fairly low for a crossover point between a woofer and a tweeter. And then with the acoustic centers being close and even the driver overlapping onto the tweeter itself, that allows them to blend really well. So when you move up, even if you move up pretty high, it's still only a minor phase rotation as far as degrees, because remember the wavelength at 1800 hertz is a lot longer than a wavelength at 2500 hertz or even 3000 hertz. The higher you go in frequency, as far as your crossover point, the closer these things have to be together in order for them to blend. That's just the simple physics of it. The further they are apart, the lower you have to cross them in frequency in order for them to blend and not sound like separate devices. So if you've got a tweeter that's a big horn tweeter and it's this tall and it's sitting on top of a bigger woofer and your acoustic centers are, 12 or 15 inches apart, well, in order for those to blend and have a seamless blend to them, you've got to cross that fairly low in frequency for them to not sound like different sources. You got to get down to where the wavelengths are longer than the acoustic centers are apart from each other. That all makes a huge amount of difference. Then that vertical off-axis changes your room response, and that changes what we hear. So when we go to design this crossover, we want to keep it in phase over a wide range. Particularly, in my mind, we want to keep it in phase as you go vertically. Not so much as you go down lower vertically, because you're looking at carpet absorbing a lot of those reflections and things like that. So you're not getting as much floor bounce in a carpeted room as you would off the ceiling. And when you stand up in the room, you want it to maintain an even response, whether you're seated or standing or moving around the room. You want it to be coherent. It's not as big of a problem if you put your face on the floor or your ears on the floor and start listening to hear if it's different there. You'd have to get basically with your head on the floor to get enough of an off-axis vertically to start really affecting it, versus if you're in the room and you just simply stand up, you're making a pretty big change. So you want it consistent over that whole range. So there's things we do in the crossover that shifts phase, keeps them in line. This one, I'll have Ron throw up a vertical off-axis measurement for you to look at. It's ideal because it maintains an even response over a wide range. And I know a lot of designers out there, they put a lot of stress on the off-axis response, but they're just looking at the horizontal. They'll say, well, this wave guide that I've got this in has controlled dispersion. Yeah, it's controlled within the off-axis left and right, but what is it doing vertically? As you move up or down, is it still maintaining that same control? And for you guys out there that are looking at speakers, thinking about designing speakers, look at that stuff. Look at the vertical off-axis. It's as important as the horizontal, or more important than the horizontal, almost as important as the on-axis response. So, if you got questions, comments, throw them down below. And that's all for today. We'll pick up next week, maybe on a new subject, maybe a little bit more on crossover design. We'll see. Thanks for tuning in. I hope this made sense to you. And that's all for today.